It's late summer, and you notice a random, heavy vine springing to life right out of your backyard compost pile. Gardeners call these surprise arrivals, volunteer plants, seeds that germinate from discarded food scraps rather than a planned seed packet. Harvesting a free squash from the compost feels like a lucky break, but eating it without testing it is a massive biological gamble. Consuming the wrong volunteer gourd triggers toxic squash syndrome. The onset brings violently painful abdominal cramps, severe vomiting, and diarrhea. In acute cases, the toxins cause physical swelling and damage to the liver, gallbladder, and kidneys. This extreme toxicity isn't a bacterial infection or a plant disease. It is a deliberate, ancient genetic defense mechanism waking up. Thousands of years ago, the entire Cucurbitaceae family, which includes all squash, pumpkins, and melons, was completely inedible to humans. They were packed with cucurbitacin, a slightly bitter, highly toxic biological compound. This creates an evolutionary survival paradox. A fruit needs animals to eat it and disperse its seeds, but the cucurbit was poisoning almost everything that took a bite. It relied entirely on prehistoric megafauna, which had fewer bitterness receptors than humans and could process the toxins without getting sick. It took massive herbivores like mastodons to stomach the poison, crush the hard exteriors, and carry seeds across the landscape, saving the plant from extinction. When the megafauna died out during the Pleistocene epoch, early humans intervened. By selectively replanting only the mildest fruits over hundreds of generations, early farmers actively stripped the cucurbitacin from the plant's genetic expression. By breeding out the poison, humans turned an inedible survival tool into a dense, reliable source of hydration and nutrients. Today, highly domesticated varieties like the ash gourd and the fuzzy melon are staple functional foods across Asian cultures. Daily markets overflow with these greens and gourds, deeply integrating them into the human diet as a primary source of hydration and nutrition. The ash gourd is roughly 96% water and naturally rich in soluble fiber. When consumed, that fiber forms a gel-like substance in the gut, which slows digestion, promotes a feeling of fullness, and aids heavily in weight management. Beyond digestion, these gourds deliver targeted health benefits. A single serving can contain roughly 76% of your daily requirement for vitamin C, alongside doses of vitamin B1 and potassium, which help stabilize blood sugar and support the cardiovascular system. Over centuries of cultivation, humans transformed these gourds from a bitter survival calorie into a potent daily preventative medicine. In traditional medicine, practitioners move beyond the dietary benefits and use extraction methods to pull specific active compounds from the plant. Modern clinical studies have homed in on Benincase exocarpium, an extract taken strictly from the powdery, ash-colored outer peel of the gourd. Clinical tests revealed this peel extract acts as an anti-hyperuricemic. This means it actively lowers uric acid in the blood, directly fighting conditions like gout and metabolic disorders. This molecular diagram shows exactly how it works. The active compounds in the ash gourd extract hunt down and physically block the XOD enzyme, a specific protein responsible for producing excess uric acid in the body. By inhibiting that enzyme, the total volume of uric acid in the bloodstream drastically drops, allowing the body to flush out the remaining waste. Protecting vital organs is the final step. Transcriptomic data proves this process significantly reduces inflammatory markers and physical swelling within both the liver and the kidneys. Laboratory analysis of these transcriptomic pathways confirms exactly how the plant's compounds communicate with human enzymes to reduce this metabolic stress. Ultimately, the result is a targeted, plant-based method for suppressing enzyme overactivity and managing the cellular inflammation caused by gout. But despite millennia of cultivation, the gourd's DNA has not forgotten its prehistoric defenses. The Cucurbitaceae family has a vulnerable reproductive system. Because they are unisexual, they rely entirely on insect pollinators to move pollen from male to female flowers, meaning different varieties cross-pollinate with ease. In a typical garden setting, a pollinating insect can easily carry pollen from a winter squash over to the female flower of a summer squash. The resulting fruit might look normal, but its seeds contain a chaotic, unpredictable hybrid of both parent genomes. When one of those hybrid seeds gets tossed into a compost pile, or when the resulting plant faces environmental stress, like a prolonged drought or extreme heat, it panics. In response to that stress, the plant reactivates its ancient DNA, spiking its cucurbitacin back to Mastodon-era levels to protect itself from being eaten. Losing control of the plant's breeding environment strips away thousands of years of domestication in a single generation. Which brings us back to the mysterious compost squash you found in the backyard. Because cross-pollination completely changes the interior chemistry without necessarily changing the outside appearance, there is a non-negotiable safety protocol before eating a volunteer plant, the raw taste test. You have to cut a small slice of the raw squash flesh and place it carefully on your tongue. Our bitterness receptors are an alarm system specifically evolved to detect cucurbitacin in the wild. If that tiny slice tastes sharp or bitter, you must spit it out immediately and discard the entire plant. Do not cook it and do not eat it. These ancient gourds offer proven medicinal properties, but their deep genetic memory demands our absolute caution and respect.